In this video, we're going to talk about matrix multiplication. All right, let's suppose we're at a store. I have two registers that only have quarters and dimes in them. Register 1 has 12 quarters and 10 dimes. Register 2 has 3 quarters and 4 dimes. How much money do I have in each register? We want to set this up using matrices. Now, I've already set it up, register 1 and register 2, and the columns represent the number of quarters and dimes. So according to our problem, register 1 has 12 quarters and 10 dimes. Register 2 has what? 3 quarters and 4 dimes. Well, each quarter is 25 1/100ths of a dollar, and 1 dime is 1/10 of $1. Now, how would I normally go about doing this? Well, I would take the number of quarters and multiply by 25 hundredths. Well, that hasn't changed. Okay. And then do what then? Then I would take the number of dimes and multiply by how much 1 dime is worth. Okay. So notice here, it's not all multiplication. There is going to be addition. Now, I'll do a similar argument with register 2, 3 quarters at 25 cents each, plus 4 dimes at 10 cents a piece. Okay, so what do I have in this particular case? I have $3 in quarters and $1 in dimes. And then for the other register, 75 cents in quarters and 40 cents in dimes. And add, I have $4 in register 1 and $1.15 in register 2. Okay, so the other thing I want to talk about here is take a look at the dimensions of each matrix. The first one's 2 by 2. The second one is a 2 by 1. And notice my answer is a 2 by 1. Okay? So in other words, if I can get these values to be the same, I should be able to multiply. And then these two values will give me my dimensions for the final matrix. So this is an example of matrix multiplication. So any m by n matrix can be multiplied by any n by p matrix. The final matrix will be what? An m by p matrix. All right, so let's take a look at these 3 quick examples before we actually do multiplication. Can I multiply a 2 by 3 and a 3 by 4 together? Because the 3's match up, I can. So that's a yes. And then the order of the final matrix is going to be a 2 by 4. Now, notice the middle example. The 5 and the 4 don't match. I can't multiply. And for the final one, notice the 10s match up. So I am going to have a 3 by 20 matrix as my final answer. All right, so let's go to the next page then. So I'm given these 4 matrices. I want to be able to calculate the following for this. All right, so A times B. So what I would suggest first is to go ahead and write them out. Now, let's take a look at the 2 matrices. It's a 2 by 2 and a 2 by 3. So yes, I should be able to multiply them. And my final answer should be a 2 by 3 matrix. Okay, so then let's take a look and see what this is going to look like then. Okay. So what I'll do first is I'll take this row and multiply by this column. So 4 times 1 is 4, and 5 times 4 is 20. But remember, I'm going to add them in between, similar to our cash register example. Now, I'm going to take this same row and multiply by the next column. So what do I have? 4 times -2 is -8, and 5 times -3 is -15. So it'll be -15. Now, I'm going to take this same first row and multiply by the third column. 4 times 3 is 12, and 5 times 5 is 25. So the first row of the first matrix is done, but now I got to do the second row and multiply by each one also. So 6 times 1 is 6. -3 times 4, that's -12. Okay. So now I take the second row with the second column here. So that's what? -12 plus 9 And now I'm going to take this third row and multiply by this third column. So that's what? 18 minus 15. So now the rest of this simplifies very easily. That's 24 and negative 23 and 37 and negative 6 and negative 3 and 3. And notice my final answer is a 2 by 3 matrix here. Okay, so now let's scroll down and then do 2 times a squared. Okay, so I can rewrite 2, and then matrix A, I'll rewrite twice. Remember, a squared, a times a. That's what I'm going to do. Now, multiplication is commutative. I can multiply this in any way that I would like. So I think what I'm going to do is I'm going to take the scalar 2 and multiply by the first matrix. Notice I'm not going to do it for both, just for one matrix. Okay, so I'm going to do that first. And I'm going to bring the other matrix with us. So again, notice a 2 by 2 by a 2 by 2. I know I can multiply these together, and my final answer is going to be a 2 by 2 also. Okay? All right, so I'm going to put this here. Okay? So I'm going to take the first row with the first column. 8 times 4 is 32. 10 times 6 is 60. Remember, it's adding in between or subtracting. Now I'm going to take the first row with the second column. So that's 40 minus 30. So now I go to the second row and multiply by the first column. That's 48 minus 36. And now I'm going to do the second row with the second column. And a negative is a positive. So now that's done. So now just add them or subtract. And we're done here. Right? So again, matrix multiplication is not all multiplication. All right. So now let's do B times C. Okay. So again, I can write them out first. So again, it is what? A 2 by 3 with a 3 by 2. So you know I'm going to be able to multiply. My final result is going to be a 2 by 2 matrix. All right, so let me draw this out. Okay, so now we'll do the first row with the first column. Now I'm going to do the first row with the second column. So now I'm going to go to the second row and the first column. And now I'm going to go to the second row with the second column. Add them or subtract. And indeed, we do have a 2 by 2 matrix to finish. Okay, now let's go to B times A. Okay. So then B, I can rewrite as this, and A. So again, this is a 2 by 3 with a 2 by 2. Notice these numbers don't match. I can't multiply. But a better way to look at it is if I take the first row here and multiply the first column, not every single number is going to be multiplied. So you know right then and there, visually, I can't multiply these. That's the end of the problem here. Okay, the last thing that I want to show then is I want to take a look very quickly at A times D. and D times A. Okay, because we already know from the previous examples, not all of the matrices multiplication is going to be commutative. Okay, but notice we have not used D yet, and that is the interesting matrix of 1, 0, 0, 1. So when I take A and multiply it by D, I get matrix A. If I take D times A, notice, as my very final answer for this, I still get matrix A. Okay, so matrix D is what is called the identity matrix, and it's a square matrix, remember, same number of rows and columns, with ones along the main diagonal and zeros everywhere else. That looks very, very similar to RREF. Okay? So, in general then, when you multiply matrix A by the identity matrix, well, we ended up getting matrix A. Okay? Now, very, very important. Number one, we're assuming the two matrices can be multiplied together, because if they're not, you can't multiply them. But more importantly here, I can write this particular statement also. Any matrix A that can be multiplied by the identity is equal to A, or the identity matrix times matrix A is equal to A. Okay. We will be using that piece of information very, very soon.